Okay, this unit, we are going to start off by looking at the case of the poisonous pill. So just to introduce the case, we have our decedent, Mary Heller. She's 19, wakes up feeling ill. Her mother suggests that she eat some breakfast, but Mary says she just wants to take Tylenol, go lie back down. Her mother digs in her purse for a pain reliever, hands it to the girl. Mary swallows the pill, goes to the bathroom, closes the door. A few minutes later, Mary's father hears a thud. He knocks on the door, but there's no answer. He opens the door and finds Mary unconscious on the floor. Paramedics arrive quickly and take Mary to the hospital. And at 9:46, she's pronounced dead at the hospital. Because Mary is so young and her death is so sudden, her case has been sent to the medical examiner's office. And while we wait for autopsy results, we're going to take a closer look at the medication that she took before collapsing. Mary's mother has given us a small plastic case from her purse where she keeps medication to use on the go. There's 5 pills left in it. It could probably hold 2 or 3 more pills. Mary's mother says that she keeps various painkillers in the case, but she's almost 100% certain that she handed Mary a capsule of Tylenol. So on your notes, there's a little bit of background reading that you'll need to pause this video and complete. The background reading will introduce the different types of medication that we're going to look at during this case. So just pause here and read the background and answer the questions. The first part we're going to look at has to do with counting atoms in a formula. So it's going to be important to know the structure or what our formulas are made of, what our medications are made of as we continue on in the case. So you're just going to count how many carbons, how many hydrogens, how many oxygens, all of that kind of thing as you're going through. So there's some pictures to kind of help you along on a few of them to get you used to it. Remember, if you see a parentheses, something like this, then we know that that 2 applies to everything inside the parentheses. So that means we have 2 nitrogens and 6 oxygens total. So don't forget to keep track of parentheses as you see them. Once you're finished, go ahead and scan this QR code. That will take you to a YouTube video that will introduce our next concept of a mole. So pause here until you're ready to continue to the next step. So part 2 is going to introduce the term mole, and we're also going to look at mole conversions. So as you saw in the video, mole refers to a number of particles. So just like a pair is always means 2, or a dozen means 12. A mole equals 6.022 times 10 to the 23rd. Sorry, that should be a superscript. So anytime you see the word mole, we are going to just know that that's equal to 6.022 times 10 to the 23rd things is the way that I like to think of it. So it doesn't matter what we're talking about. It can be a mole of donuts, and that means you have 6.022 times 10 to the 23rd donuts. So a mole is just another word like dozen. It just refers to a number of things. So since Mary's death was related to the medicine, or if it was related to the medicine, this mole concept can be helpful for what we're doing. So this word is also important. As you saw in the video, Avogadro was the guy who kind of discovered this concept. So we refer to this number as Avogadro's number. So if you hear that, just know that it's referring to 6.022 times 10 to the 23rd. So why do moles matter? Moles are important because atoms and molecules are too small to see individually. So we have to think of them like a group. So just like it would be difficult to go to the store and buy your eggs individually, it's easier just to go grab a dozen of eggs in a carton that have already been divided for you. That's why we use mole instead of atoms or particles or molecules, because it's easier to think of them as a whole group where we can see them as compared to when we being too small that we can't see them. So when we do our mole calculations, if you remember this picture, we always want to make sure that we're canceling out the units that we don't need anymore. And remember, the way that we cancel them out is we take whatever's on the top and we put it on the bottom so that it will cancel out. So the way that I get my yellow triangle is because the top and the bottom canceled out, so I'm left with the yellow triangle. Same thing for number 2, my green stars cancel, my red hexagons cancel, so I'm left with heart over lightning bolt. So as we start setting up our calculations, we want to just remember, whatever we have, we want to make sure we can cancel it out with the units on the bottom. So for our first calculations, remember, we always start with what we're given. So in this case, we're given 1 mole, and I want to know how many molecules. So when I set up my train tracks, since I have moles on top, I know I want moles on the bottom, and one way that we abbreviate mole is MOL, just lose the E. And I know that in 1 mole, there's 6.022 times 10 to the 23 molecules. Okay, so now, let me change colors. Moles are canceled out, so we're left with just molecules. And remember, anything on the top gets multiplied, everything on the bottom gets divided. So in this case, since we have just a bunch of 1s, we just have 6.022 times 10 to the 23 molecules, which makes sense because we're just talking about 1 mole, and we just said 1 mole is equal to 6.022 times 10 to the 23rd. So for number 2, it's asking about 2 moles. So you may already be thinking in your head, oh, I'm just going to multiply 2 times Avogadro's number, which would be correct. So the way that we know that we're setting that up correctly in our head is we can set it up correctly on paper. So 2 moles is what I was given. That's what I'm going to write down first. Since I have moles on top, I know I want moles on the bottom, and that's always equal to 6.022 times 10 to the 23rd molecules. So now I'm just going to multiply the top, divide by the bottom, so you end up with 1.2 times 10 to the 24th. And there may be some decimals after the 2 that I can't remember, but as long as you get something close to that in your calculator, then that's fine. If you want to pause here so that you can try practicing setting up number 3, then you can restart the video when you're ready to check your answer. So I set this one up the same way I set up the previous questions. Moles get canceled. This is something like 3.6 times 10 to the 24th. The next set of questions is using the same concept, except for we are converting from molecules to moles. So again, I'm just going to start with what I'm given. This is molecules. Set up my train tracks. I know that if I have molecules on the top, I want molecules on the bottom. And it's always 6.022 that goes in front of my things. Remember, because that is equal to 1 mole. So now my molecules are going to cancel. And then when I type this in my calculator, I'm going to divide the top by the bottom, and we end up with just 1 mole, which makes sense because we know that this is the same as Avogadro's, so that's how many particles are in a mole. Number 2, you would set up the same way, and number 3. So if you want to pause here, try to set them up yourself, then you can resume the video and watch me complete the questions. So in both questions, I set up so my molecules were on the bottom, so they would cancel out with the molecules on the top. And then you're going to divide by 6.022 times 10 to the 23rd. The main thing here is don't forget to use your parentheses when you're dividing, because you're using that exponent, that times 10, and you don't want it to accidentally apply to everything in the question. So make sure you're doing your parentheses. So if you flip over to the back of this page, you'll see that now we have our examples from our different molecules and our different medicines. So you're going to do the same types of calculations. You're just now figuring out how many moles or molecules were in our different medicines. So depending on what you're given, you're always going to start with what you're given. Okay, and then use your Avogadro's number to convert back and forth. Once you finish that section, you're going to move on to the molar mass section. We are not going to do this whole part today. We'll just do the kind of introduction page. So you're going to stop after B3. These kind of walk you through and give you some good examples of how to find the molar mass of elements and compounds. So just to kind of introduce you to the first 2 questions, your molar mass is always going to be the same as your average mass. So for example, like let's think about chlorine. Okay, chlorine's average mass is 35.45. That is also the molar mass. So the way that they determined the average mass is they grabbed a mole of the sample, place it on the scale, and then that is the average of all the isotopes that are in existence for 1 mole of sample. So they're the same thing. So if I want to find the mole of lithium atoms, I'm just going to look at the periodic table. Okay, and then I know that this answer right here is the mass. So the mass of 1 mole of lithium atoms is 6.941. If we want to find the mass of the compound, we're going to look at all of these individually. So you'll find silver, nitrogen, and oxygen on your periodic table, and then we're going to add them all up, okay, based on how many we have. So I only have 1 silver, 1 nitrogen, but for oxygen, there's 2 of them. So when I start adding up, I need to take that into account. So silver is 107.87, nitrogen is 14.01, and oxygen is 16. So the only one that I really need to do anything to is oxygen, because it really becomes 32. And then now when I add all of these up together, you should get something like 153.88 grams. So when we're looking at a mass of a compound, we want to look at everything individually and then add it all up together. So you have a few other questions. You have an A2 and an A3 and a B2 and a B3 that you need to answer on your sheet, and then we will pick back up with this during the next lesson.